Laplace transform is an incredible power piece of mathematics. It is integral transform used to transform from time domain to frequency domain. And this process will happen through this integral. To convert the function f of t from time domain to frequency domain, we should compute the value of this integral. And to compute the value of this integral, the function f of t, it should satisfy two conditions. The time domain function should be piecewise continuous function, and the time domain function f of t must be exponential order function. Those two conditions will give you the ability to convert from time domain to frequency domain through Laplace transform. In those examples, let's illustrate the way to compute Laplace transform for different functions. In example 1, we will try to compute Laplace transform for number 2. Then the transform of number 2 equals to 2 itself divided by s. Here in example 2, let's try to compute Laplace transform for negative value, or for negative 3 suppose. Then the answer it will be, I will take the number itself, negative 3, and I will divide that by s. Here in examples 3, we will take Laplace transform for positive fraction number. Then the answer will be, I will take the same number itself, 5 by 2, and I will divide that by s. By the same way, the Laplace transform for negative fractional number, it will be take the same number itself, negative 3 by 4, and divide that by s. Then the conclusion here, the Laplace for any number k, it will be the same value of k but divided by s. In example 5, let's try to compute Laplace transform for the function t. The answer of that directly it will become 1 pi s squared. In example 6, we would like to compute Laplace transform for the function 3t. As you know, Laplace itself is just integration. Regard that I can shift this 3 outside the integration, where 3 just constant. Then it will become 3 Laplace t. Then this 3 it will come down with me, and Laplace t, as we know, it will become 1 pi s squared. Then finally it will become 3 pi s squared. In example 7, I will try to compute Laplace transform, but here for two terms, between them additions, as you can see. For that, I will compute Laplace transform for each term separately. Hence, Laplace transform itself, its linear operator. The Laplace transform for 3t, as we did before, it will become 3 by s squared. And the Laplace for number 5, it will become the number 5 itself, but divided by s. Then in general, you can say the Laplace for any number k multiplied by t, it will give the same number k, but divided by s squared. In example 8, let's try to compute Laplace transform for the function t squared. Correct, I will take this power here, it will be 2 factorial. And down I will write s to the power, the same number 2, but I will add 1 extra. As you know, factorial 2, it's mean 2 multiplied by 1. And down I have s to the power what? Power 3. Then the final answer, it will become 2 divided by s to the power 3. In example 9, let's compute Laplace for t cube. Then first of all, I will take the power here, which is 3. I will make it factorial. And down it will be s to the power 3, and then I will add 1. 3 factorial, it's mean 3 multiplied by 2 multiplied by 1. And down here I have s to the power 4, which it will become 6 divided by x power 4. Moreover, to compute Laplace transform, but for t power 4, then it will become, I will take the 4 here, it will be 4 factorial divided by s to the power what? 4 plus 1. Then 4 factorial, that's mean 4 multiplied by 3 multiplied by 2 multiplied by 1. And down here I have s to the power 5. which it will be 24 divided by s to the power 5. Then in general, Laplace transform for the function t power n, it will become, I will take the n there, it will become n factorial divided by s to the power n plus 1. In example 11, let's try to compute Laplace transform for the function 3t power 4. At the beginning, I will shift the 3 outside the integration, or outside the Laplace transform, which it will become 3 Laplace for t to the power 4. After that, 3 it will come down, and the Laplace transform for t to the power 4, it will be 4 factorial divided by s to the power 5. The answer, as we did before, it will become 24 over s to the power 5. Now you can multiply just 3 with 24, which it will give you 72 divided by s to the power 5. In example 12, let's try to compute Laplace transform for two functions, between them addition. Then surely you can do them separately. Then I will compute Laplace transform for t square alone plus Laplace transform for t cube alone, which it will give me, for the first one I have the power here 2, then it will become factorial 2 divided by s to the power 2 plus 1, which is 3, plus the second term with power 3, it will become 3 factorial divided by s to the power 3 plus 1, which is what? 4. 2 factorial just 2, then it will become 2 divided by s 3, and 3 factorial, which is 6 divided by s to the power 4. Again, here we will try to compute Laplace transform for the exponential function 3t. The answer will be directly 1 by s minus the power here, the coefficient of the power here, which is 3. By the same way, to compute Laplace transform for exponential negative 4t, the answer will become 1 divided by s minus the coefficient of the power here, which is negative 4. As you can see, the negative, it will become s plus 4. And again, to compute the Laplace for two terms, you can split them to be the Laplace of the first function, e to the power 2t, plus the Laplace of the second function, which is e to the power negative 3t. Accordingly, the answer it will become 1 divided by s minus the coefficient here, which is just 2, plus 1 divided by s minus the coefficient here, negative 3, it will become plus 3. Then in general, the Laplace transform for the function e to the power at, this is equal 1 by s minus a, and the Laplace transform for e to the power negative at, it will become down positive, then s plus a itself. Now we will try to compute the Laplace transform for the trigonometric function sine 3t. The answer here equals to 3 parts in this form. In the first part, I will put the coefficient of the angle, which is 3, and I will put it down, but I will make it a square, and in the third one, I will put s square. Then the answer, it will become 3 divided by s square plus 9. By the same way, the Laplace transform for the function sine 4t equals to this fraction, and I have here 3 boxes, as you can see. Now the coefficient of the angle here just 4, then I will put here 4 and here 4 square, and then here I have s square. It will give me 4 divided by s square plus 16. Now let's compute Laplace transform, but for the function cosine 3t, which it will give me the same form, but with a slight different. In the case of cosine, I will put first s, and then I will make it a square down, and after that I will make squaring for the coefficient, which it will become just 9. Then again, to compute Laplace transform for cosine 4t, this it will give us, at beginning I should put s and s square down, and the coefficient here just 4, which it will become 16. The final answer, it will become s divided by s square plus 16. Then hence the Laplace, its linear operator, then you can compute it for each term separately. Then Laplace sine 3t plus Laplace for cosine 4t, which it will give me, as you know, this form for the both cases. First, for the sine, I have here the coefficient just 3, then it will come down to be correct 3, make it a square, it will be 3 square plus s square here. But for the case of cosine, it is different. First I have s and then s square, and the squaring of 4, it will become down 4 square. Then the final answer, it will become 3 divided by s square plus 9, and here I have s divided by s square plus 16. And to compute Laplace transform for the function 3 sine 4t, I should shift this 3 first outside the Laplace, then it will become 3 outside, and then remain with me Laplace sine 4t, which it will be 3 multiplied by 4 divided by s square plus 16. Now you can just multiply 3 and 4, which it will give us 12s square plus 16. Now you can solve those problems and share your solution with me.